Dilation. Dilation is a transformation in which a figure is made larger or smaller with respect to a fixed point called the center of dilation. Now, you see this all the time on your smartphones. Anytime you do a pinch zoom, that's a dilation. The original figure and its image have the same shape, but not the same size. So the size is the only thing that's going to change. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor. So by how much it increases or decreases is the scale factor. In order to dilate a figure in the coordinate plane, you're going to multiply the coordinates of each of the vertex by scale factor, and we refer to that scale factor in terms of k. So if k is greater than 1, the dilation is going to be an enlargement. It's going to increase in size. When k, or the scale factor, is less than 1, it's going to be a reduction. Now, the smallest reduction could be is down to just above 0, so it can't be less than 0. The first image we're going to look at is triangle ABC, and we're going to dilate that by a scale factor of 3. So the first thing we'll need to do is to plot our points. Next, we're going to multiply both x and y coordinates by a factor of 3. Therefore, 1 times 3 is 3, and 3 times 3 is 9. 2 times 3 is 6, 3 times 3 is 9 again, and 2 times 3 is 6, 1 times 3 is 3. Of course, now we have to plot those points. So a prime over 3 up 9, b prime over 6 up 9, and c prime over 6 up 3. So this blue triangle is the dilated image of the red triangle, and it's been dilated by a scale factor of 3. Looking at a second example, we're going to draw the image of a rectangle WXYZ after a dilation with a scale of factor of 1/2. So this is going to decrease in size. Our initial points will be these right here, so we'll need to graph those first before doing our reduction. This time we'll be multiplying both our x and y coordinate by 1/2. That, of course, is the equivalent of dividing each by 2. These are the coordinates of our dilated shape. And this is the result of our dilation. Now, a helpful study tip is you can check your answer by drawing a line from the origin through each vertex of the original figure. Vertices of the image should lie on these lines. So let's look at our previous example to demonstrate this. Here's our image prior to drawing lines through the vertices, and after. This will work with every dilation that you do.